Yeah, so in trigonometry, this is just a topic that deals with measurement of angles and distances. So this whole topic is just going to be us measuring angles, doing measurements. That's what we're interested in. So the first thing that you're going to learn are units that we use to measure these angles. So we already know about degrees. Now we're just going to introduce one more thing, which is called radians. So there's this conversion factor that we're going to be using. So we're going to talk about conversions. That's the first thing we're going to discuss. So under conversions, we're just saying every 360 degrees is simply going to be represented by what we call 2 pi radians. That's what you have. So on your calculator, if you're using a Casio, there is when you click on mode twice, there's going to be a section that's going to come, that's going to be written as DEG, and then one will be R, this guy here, then there's going to be this other guy. This is on option 1, option 2, option 3. What we are talking about is radians, option 2. So radians is another measurement, is another unit that we use for angles, and it's simply going to be given in terms of its relation with pi. So this can also be reduced. We can reduce this to be, by reducing I mean we can also divide both sides by 2. Some people would opt to say 1 pi radian is the same as 180. Some people would love to use this instead of the 2 pi is equal to 360. So in case you're wondering why are we doing this, we're just doing this to tell you that someone who is going to be right 30 degrees is correct as compared to someone who is also going to write the same thing as pi over 6. Where is the pi over 6 coming from? We just converted the 30 degrees into radians. So if I say 1 pi is equal to 180, then how many pi's are going to give us 30 degrees? We're just trying to convert the 30 degrees into radians. So pi by 30, that's going to give us 30 pi. This is going to be 180x dividing by 180. This is also going to cancel. So x, you're saying the 0 is cancelling. 3 there is 1, 3 there is 6. That's where the pi over 6 is coming from. So next time when you see someone writing 45, you should be okay with someone who is going to write your pi over 4. Someone who writes what, a 90 degrees, you should be okay with someone who writes pi over 2. We're just saying we can measure angles both in radians or in degrees. So you can have degrees or radians. It's one and the same thing. That's basically what we are saying. Yeah. Is this okay, guys?
Yes, it's okay.
It's okay this because mostly in questions they will be giving you questions in radians. So instead of saying, for instance, 0 to 360, they'll just say 0 to 2 pi. Yeah, so you have to notice it's the same thing, just that it's a different unit of angles that we're using. So now if you're okay with these conversions, we can now come at trigonometric functions. So there are 3 trigonometric functions that you're going to learn. There's sine, there's cosine, then there's tangent. That's what you have. The shortcut of sine is, it's written like sin, but we pronounce it as sine. Then this is going to be cos, we just write it like that. Then tangent is simply written as tan. That's the shortcut that we'll be using. So if you have a right angle triangle, you remember your Pythagoras theorem. If you have a right angle triangle like this, for instance, let's say this is your 90. Let me try to make this a bit more straight. Yeah, so if you have something like that, if you are discussing your angle here, let's put the theta to be here. You know to say this is going to be your opposite. This is going to be your hypotenuse, the longest side. This is your adjacent. Opposite, then you have hypotenuse, then the guy down here is adjacent. So we just use the guy that you learned. So we say what you called it SOHCAHTOA. This is what you are using. So this means that if I give you to find, let's say, to find the theta using the sine ratio, you're simply going to say sine theta is the same as, you're going to get the opposite, which is O, then over the hypotenuse. That's what you have. The same applies to the cos. You say adjacent of hypotenuse. Then you do the tan as well. So maybe let me just show you everything. Cos theta will be adjacent over hypotenuse. Then tan theta Tan theta will be opposite over adjacent. Now just right here, let me show you something. I know it's a little bit too early, but I just need you to see it. When you divide the sine and the cos, you're simply going to get the expression for tan, which is O over A. So I'm saying if you divide the sine theta over cos theta, this is going to be sine of z opposite over hypotenuse divided by, I'm dividing it by adjacent over hypotenuse. When you work it out, when you change the division into multiplication, it's going to be h over a. You notice this becomes o over a, which is exactly tan. So in short, there's what we call an identity. An identity is like how you say what those that are doing trigonometry at the moment, we identify them as what math 11, 20 students, right? They're the same people, but we're just having two different names for them, right? So we're just saying the division of sine and cos can also be just called tan. Tan is equal to you just dividing whatsoever you have for sine over the cos that you have. So this is the first identity that you ever learn. Yeah, so we're just saying if I give you a right angle triangle and you know that the distances, so I use a 3, 4, 5 triangle. So if I give you this, yeah, if this is your angle here, let me just call it theta. So this is, let me say 3 and this is 4. You know how to get this. You can use the Pythagoras theorem, right? You already know to say the hypotenuse squared is always equal to the opposite squared plus the adjacent squared. So this is going to be 5. That's what you have. So if you're looking to get the size of theta, we already know this is 90. What we don't know are these two angles. If you're looking to get theta, you can use sine. Sine theta is equal to, you say opposite, which is 3 over what? 3 over 5. To get the actual size of the theta, you simply say what? Theta is equal to sine inverse of 3 over 5. Or some people say theta is the same as arc sine the 3 over 5. That's what we mean. You punch it by saying shift sine on the calculator. You punch shift, then sine, then 3 over 5 equal to, so if you actually punch this on the calculator, it will give you 36.86 degrees. That's what you have. Now, of course, you guys don't use calculator, so I'm going to teach you how we're going to be working out things without you needing the calculator. Yeah, for this expression, we need, there is no exact angle for 3 over 5, so no wonder I just use the calculator. Hope everyone is okay on how we are getting the shift sign. Hope you remember this. If I give you two distances, I'm saying, and I'm asking for this angle here, this is basically what you do. You can use any ratio from the sine, the cosine, and the tangent, because you have all the three sides. Yeah, so but mostly they'll just give you two sides, then ask you to find the angle that you have. So like in this case, you will be forced to just use what? You have opposite and adjacent. You have no choice but to use what? To use the tan option. Then they also have twins. They also have inverses, so to say. So not only do we have the sine, cos, and tangent, but they can also give us their inverses. Yeah, so their inverses, there is cosecant, which is what we're going to be calling cosec. Then there's secant. Then there's cotangent. These are the full names. Yeah, but the shortcut, this will be just cot, which is just the same as cot is 1 over tan theta. The inverse of tan is what we call cot. Yeah, then we have sec. Sec is just 1 over cos. The inverse of cos is what we call secant, which is sec. Then cosec is simply the inverse of sine. That's what you have. Yeah, so if I give you to say, for example, sine theta is equal to 3 over 5, like the previous case, I ask you for cosec, meaning cosec is simply what? 5 over 3. Just flip whatsoever you have there. That's what we mean. Is this okay, guys? Just on the inverses. So these inverses will come in play when you talk about identities. I'll bring them back later on. I just wanted you to know, to say we have, these are called trigonometric inverses. Yeah, if I was to put a title, these are the inverses. Yeah, like how you learned under functions to say every normal function needs to have an inverse, right? You can get the inverse. So these are the inverses of these trigonometric ratios. Now, we said we're not going to be using calculator. So how are we going to be solving things? We're only going to be solving things using what we call special angles. So these special angles are very important. You have to master them, in short. So the special angles that you guys have to know is just 30 degrees, then also 45 degrees, then there's also 60 degrees. Because from these three, you can actually create anything that you want. Yeah, so the first one, the 30 and the 60, comes from us having a triangle that looks like this. So a triangle that has three equal sides, we call it what? An equilateral triangle, right? If you have 60 there, then you have 60 there, and you also have 60 here. The distances, the length, the sides will all be the same because this is an equilateral triangle where all the angles are equal inside. Now we're going to cut this thing in half. If we cut it here on the middle, meaning the 60 which was here on the corner will be shared into two equal parts. So there's going to be a 30 this side and there's going to be a 30 this side. So I'm just going to take one of the triangles and just redraw it here. So the triangle that I've taken here, it's a 90, it makes an angle of 90. So we've cut this guy on the middle, meaning this was 2 units, now it's going to be 1, 1. So this is a 1, then this is a 2. And if you use your Pythagoras theorem, of course, this side is a 60, and here the angle is a 30. When you use your Pythagoras theorem, we have the longest side, which is 2 squared. It's supposed to be equal to the shorter distance, which is 1 squared, and the other guy, which is unknown, let's call it x. So x squared, this is going to be a 4 minus 1. This is x squared. So x just becomes root of 3. So you should be okay by us saying, where there's x, we can put root of 3. That's what you have. Now, I'm going to erase this part to give you ratios for sine 30. So if I give you sine 30, according to 30, where you are here, sine 30 is what? Opposite over hypotenuse, right? So sine 30 is the same as 1 over 2. Is everyone okay, guys, with this triangle that I've created? Anyone who is lost so far? Betha, are you okay with this? Okay, so sine 30 is simply going to be half. Then I'm also going to have cos 30. So with regards to 30, the opposite is 1. The adjacent is root 3. The adjacent and the opposite can switch places. The only thing that is permanent is the hypotenuse, the longest side. Yeah, so according to 30, cos 30, so cos 30 adjacent is root 3. Adjacent over hypotenuse, so it's simply going to be a root 3 over 2. Then tan 30, let me put the 30 there. So tan 30 is equal to opposite. This is what SOHCAHTOA, right? Opposite over adjacent, which is 1 over root 3. So you have 1 over root 3. That's with reference to the 30. Then what of the 60? What of sine 60? Because in this triangle we have two angles, 60 and 30, and here it's a 90, giving us a total of 180. Sine 60, according to our 60, our opposite is root 3 now. So according to 60, our opposite is root 3, so that's going to be opposite hypotenuse. So this is going to be root 3 over 2. Then cos 60 is just going to be half adjacent hypotenuse. Then your tan 60 is equal to opposite over adjacent, so that's going to be root 3. So you need to know these 6 rules here, the ones that we've mentioned here, these guys that we have listed here. You need to master them. Yeah, you need to know all of them. Yeah, all the 60 and the 30, everything here. And if you can't master them, it's better you just master this triangle, because you can just be coming up with it and you derive anything that you want. So that's basically what we have in terms of these special angles. So hope this is okay. And apart from, we've already done the 30 and the 60. So next time when I say sine 30 is half, you know where it's coming from. You don't have to ask Yachoka could half because of these. These are special angles. They are fixed. They are permanently always going to be like this. So even if I change and put radians, even if I say sine pi over 6, you know pi over 6 is what? Is 30. Quickly, you know to say it's going to be half. Yeah, so these are special angles. The last one is 45. How do we get the one for 45? So 30 and 60 were gotten from an equilateral triangle. Now we are going to get this 45 from an isosceles triangle. Isosceles is where only two sides are equal, but one side is different. So I'll put a 1 there, I'll put a 1. This is a 90, meaning this is a 45. And this guy here is a 45, meaning this is going to be root 2 if you check it out because of your Pythagoras theorem, right? Your longest side is equal to the two shorter sides. So in case someone just needs to see this, we know to say x is going to be equal to root 2. So hope you're okay with me saying root 2. And you will notice that if I ask you for sine 45 is just going to be 1 over root 2. Some people actually rationalize this. So don't be shocked with someone who is going to write root 2 over 2 to say achukakut. They just rationalized this by multiplying with root 2 throughout. The same will apply for cos 45. Cos 45 will be also the same. Then tan 45 is simply going to be a 1. Yeah, because that's what opposite over adjacent, right? Yeah, so these are the 3 extra special angles, formulas that you need to master. Hope this is okay, guys. Any questions up to this point? The next part that I'm going to talk about is on quadrants. So the x or y plane is going to be demarcated into quadrants. So this is going to be given like this. We know to say if this is your operation, your x or y plane, from here this is 0, this is 90. So now I'm going to make sure that you get used with radians. So I'm going to be using radians. This is simply 90. Then here this is 180. Then here this is 3 pi over 2. That's 270. Just before we have what? Before we have 0, we can reach 360, which is just 2 pi. So this is called the first quadrant. This is your second quadrant. This is the third quadrant. And this is your fourth quadrant, right? That's what you have. So all the trig ratios here are positive. So all the trig ratios here are positive. I'll just show them positive. So cos, you have the sine, you have the what? You have the tan. The same applies here. So let me just say this. I'll just use this mnemonic that you guys used to learn. All the trig ratios here are positive. Then here only the sine is positive. The other two guys are negative. Then here only the cos is positive. Here only the tan is positive. The other two guys are negative. So in case you're wondering what we mean by sine being positive and cos being negative, so I'm going to draw triangles in each quadrant that is going to explain that. So like in the first quadrant, if I was to put a triangle here and say theta, you notice that the movement in the x component, if I may use that language from your physics, the x component here in the first quadrant is positive. You see that? The y component here again is what? Is positive. So even this guy, the error that you're going to get, you know this is your resultant, right? The resultant is always positive because remember how you get your resultant from your physics. The resultant is always this. That's the hypotenuse, isn't it? So whether sine theta, cos theta, or tan theta, they are all going to be positive because the x and the y component are what? Are positive. That's the reason why all the trig ratios are what? Are positive in the first quadrant. So in the first quadrant, angles are from 0 to 90. These are also called acute angles. These are angles that are less than what? Less than 90. And I must mention that angles are measured in the anti-clockwise direction. This is how we measure the angles. That's what you have. So if you measure an angle in the clockwise direction like this, you take the reading to be negative. I hope you got that point, guys. We're measuring angles in the anti-clockwise direction, and the reason why angles are positive, I mean all the trig ratios are positive in the first quadrant, is because the x component and the y component are what? Are positive. That's the reason why all the ratios are positive here. Then for our second quadrant, why is sine the only positive one? Because look at this. If I have a triangle here, this is my theta. The x component is negative. The y component is positive because we're going up. Then you have error there, right? Look at what you are having. If you try to find sine theta is opposite over hypotenuse. Opposite over hypotenuse. Then if you have the cosine, the cosine, so if you have cos theta is simply going to be adjacent, which is negative x, over hypotenuse, which is just r. Then if you're looking for tan theta is simply going to be opposite over adjacent, which is negative x. So you see that the only positive one that you are having is simply going to be the sine. This is the only positive trig function. The other two guys are negative. Yeah. So this is basically why we are saying this. We can show the same. We can show the same in the third quadrant and also in the fourth quadrant. Any questions, guys, here? Are you okay with what I'm explaining here, guys? Joseph, you're following, right?
There on code, is code not supposed to be the other one? The other one?
Oh, here, yes, this is supposed to be the book of Acts, yes. So it's supposed to be ACT, yes. It's supposed to be the book of Acts, right? Yes, supposed to be like this, yes. This is okay, right?
Yes.
Because if you put a triangle here in the third quadrant, you see that the x and the y component are both negative. Yeah, so if you have a negative here, so you have negative and negative. So let's say I put your triangle where you put your triangle like this. The base of the triangle always has to be in corresponding with our x-axis. So you put your angle there. The reading here is the y direction, y steps in the negative direction. Your r is 2 positive. So your angle is 2 here. So even if you say sine what? This is according to the third quadrant. Let me write it here. So according to our third quadrant, you say sine theta. Sine theta is equal to opposite, negative y, then over hypotenuse, which is r. So it's negative. Your cos is what? Cos is adjacent, negative x, over, we say over the hypotenuse, which is r. Then tan. So tan is the only one that will be positive, because tan is going to be equal to opposite. Is it opposite over adjacent? So negative and negative. This guy becomes positive. Yeah, so please take note. In short, guys, what I'm saying is that provided you are on the x or y plane and you're punching your angles, so here we're saying our angles range from 0 to pi over 2, that's 90. Here angles range from 90 to pi, 90 to 180, right? That's the second quadrant. Then here angles range from 180 up to 270, right? Then here angles range from 270, 3 over 2 pi to 2 pi, that's 360. If you punch anything like sine 30, here, anything 30 is from this interval, right? So the answer has to be positive. That's what I'm saying. Then here, if you punch sine, let's say 120, 120 is in between 90 and 180, right? This is still going to be positive, but cos 120 is going to be negative. Then sine, tan 120 is also going to be negative. That's what we mean by saying all the trig ratios here are positive, then here only sine is going to give you a positive answer. The other two will be negative. So that's what we mean here. Tan of any angle between 180 to 270 is going to come out positive. But for the other two guys, the answer is going to be negative. That's what we mean when we say a trig function is negative in a certain quadrant. Hope this is okay. Okay, so if that's okay, then allow me to just also talk about this next part here. Let me see if I can use this. I'm using this as your example for the quadrants that I'm discussing. So I'm using this as an example. Question 2. Yeah, so question 2, they're saying in the following, one of sine, cos, and tan is given. That's what we have. Find the other two if x lies in the specified interval. So the specified interval, like here, they've given us between what? This is a 90 to 180. So here we're dealing with the second quadrant, right? That's what we have. Then here they're saying cos x, we're dealing with what? 0 to, this is negative 9. This is the fourth quadrant, if you pay attention, because this is negative 90 to 0, right? The only time you can see negative 90 is if you're measuring from here up to going down like this. This is negative 90. This will be negative 180. This will be negative 270. Then this is going to be negative 360. We said angles are supposed to be measured in the anti-clockwise direction. If you take them to be in the clockwise, then you read them as negative. So this is basically what we are having. That's the reason why I'm saying this is the fourth quadrant they're asking us about. Yeah, so this is the fourth. I'll just write the 4 there. You have to identify the quadrants first. Then here you're having what? 92. This is 90 to 270, right? So 90 to 270. 90, we are here, to 270, which is down there. So you need to just identify the correct quadrant before you start solving. So between 90 to 270, where do we find tan to be positive? This is tan. X is 1 over 2. Where do we find tan being positive? It's what? It's the third quadrant. So here we know we're dealing with the third quadrant. Of course, they gave us two guys to choose from. They gave us a region from 90 to 270, meaning it's accommodating the second and the third quadrant. But the only place where tan is positive is in the third quadrant. Yeah, okay, so maybe to solve these first 3, to just show you what we are discussing, they're saying find the other guys. They've given a sign already. So they're saying sine 3 over 5, sine x, sine x is equal to 3 over 5. This is in the what? We have identified to be in the second quadrant. This is in the second quadrant. So meaning, I'm going to write it like this. So I make a triangle that looks like this. I'll show you this is method 1 that I'm going to make. Method 1. So method 1, we follow the normal XY plane. So I create something that looks like this. This is what I'm having. I create my x to be there. We're in the second quadrant. Sine of x is opposite 3 and hypotenuse, that's a 5. So already we know to say this component here has to be negative, right? So we solve for it. So I'll call it P. We don't know it, so I'll just say 5 squared is equal to 3 squared plus P squared, right? This is going to be a 25 minus 9. This is P squared. Then this is going to be a 16 is equal to P squared. We square root, we know to say the answer can either be positive or negative. We want the negative one because we are on the x component, which is negative. So meaning here, the reading is actually negative what? A negative 4. Then once you are done getting this, you can find anything that is missing. Because they've given us what? They've given us sine. So meaning we're looking for cos and tan. That's what the question is saying. One of the following is given, sine, cos, and tan. So you need to use what you are given to get the other missing 2. So the other missing 2 is going to be cos x. Cos x is just going to be adjacent over hypotenuse. That's what you get. Then your tan x is equal to 3 over negative 4. So this is what was missing. This is how we answer question number 1 here on 2. Question 2a. That's how we answer it. Is this okay, guys? Any questions up to here? We figured the quadrant first. Then after the quadrant, that's when we identify the nature of the other 2 guys that are missing, whether they're going to be positive or negative. Any questions, guys, here? Maureen, is this okay? Betha, Daniel, is this okay, guys?
Yes.
Okay, so let me do one of these guys that I've not discussed yet. So let me say randomly, I just pick this one here, right? Let me pick D on number 2. So you look at the interval given this side. So the interval they are saying that's from. So I told you to say you can either use method 1 or method 2, right? Method 2 is the easiest. You could have just created a triangle. Just make up a triangle to say you have something like this. Then you put your x there, right? Then you know to say sine gave us 3 over 5, opposite 3 over 5 like this. Then get this side. Of course, you get a positive 4 when you use your Pythagoras theorem. Then you get your what? Your cos x, which is just going to be what? Cos is what? Say what? Adjacent. Is it 4 over hypotenuse? Then you put a negative in front. Reason, you put a reason. You say second quadrant. That's the reason why you're making it negative. Yeah, then you do the same for the tan as well. Then you also get it and put a negative with a reason to say where what? In the second quadrant. You can do that if you want. But doing the x or y plane is just a sure way of you not making a mistake, and it shows that you understand what you're doing and you know why that particular trig function is either positive or negative. So look at this guy here. They've given us cos x to be negative 5 over 13. Now, this is okay. Don't even mind this. Cos of x to be negative 5 over 13. Now, the negative could have either been on the 5 or the 13, but where exactly is the negative supposed to be? So you look at the region given. They've given us pi over 2 to pi. This is between 90 to 180, right? That's the region. So I'm just converting the radians into degrees. If you're okay with working with degrees, make sure to be converting your angles, the interval you're given, first of all, into degrees before you start using it, so that you don't make mistakes. So now, which quadrant is 90 to 180? This is the second quadrant. Now, you know, in the second quadrant, a triangle is always supposed to be like this. We're here in the second quadrant. That's between 90 to 180. We know to say x is going to be equal to what? Whatever x is adjacent. So adjacent is the one that's negative. So the negative is actually with the 5. Then hypotenuse, which is 13, is the one that's supposed to be positive. So this is now going to be, we say 13 squared is equal to your negative 5 squared plus the guy that we don't know this side. I'll just call it p. By the time you are done, this is 169 minus 25. This will be p squared. This will be 144 is equal to p squared. You get your p to be 12, meaning here you get a what? A 12. Now that you know the three sides, you can get the other two missing, guys, which is sine. You know sine is going to come out positive. So sine x is equal to opposite over hypotenuse. Then tan x is equal to opposite 12 over negative 5, which is this, which is negative. So this is basically what you get. So that's how you answer every single question on number 2. Is this okay, guys? Any questions here? Which question here should we do in case you want us to do one more extra example? Which question should we do here? Joseph, are you okay with this?
We can do B.
B. So B, because of the 2, you are hesitating to put a 1 at the bottom. So they're saying tan x. We know they've just said 2, right? You can put a 1 at the bottom. Makes life a bit easy because you know every number has a 1, right? So this now is going to have what? This is 0 to 90, meaning we're in the first quadrant. Yeah, so we are dealing with 0 to 90. That's what we're dealing with. So we just come here and say, we check first. So this is going to be what? This is going to be, tan is what? Opposite, is it? Opposite. Then if it's opposite and adjacent, meaning there's a 1 here. So what's the answer here going to be? The answer here is going to be 2 squared. So this will be root of 5. By the way, this is your x. I've gotten my root of 5 by squaring this, adding the square of that. So you can get the rest of the expressions. And they're all going to be positive regardless. Sine, which is 2 over root 5. Then cos, you do the same thing, is adjacent of hypotenuse. This is root 5. I mean, you can rationalize if you want, or just leave it like this. It's still okay. Is this okay, guys?
Yes.
Yeah, so it's really the same principle over and over again on question 2. That's what you have. Then let me just check if there's anything that we have done so far. So these are all supposed to be under, okay, this is under rules. Okay. Okay, so for now, with what we've done, let me use the next few minutes that are remaining. We still have like 10 more minutes. So we've just done the conversions, we've done at the quadrants. So now let me try to explain a bit of the following rules, or identities rather, because these are going to be very important. So I'll just call them rules because people always hate them whenever we call them identities. So the first identity that we discussed was that sine of theta over cos of theta is always going to be the same as tan of theta. It's just a rule that says this is equal to that, right? Then so I'll show you how we derive them. The second one is if I give you a unit circle, for instance. So a unit circle is just a circle whose radius is 1. Yeah, that's what we have. That's what we call a unit circle. So if I was to give you a triangle face that looks like this, this is your x component, this is your y. Remember from physics, you said what? According to this, X component is simply the same as what? R, then cos theta. Then your Y component, you said it's the same as what? You said it's the same as R sine theta, right? That's what you said. So from here, you know, again, you know to say R squared is the same as Y squared plus X squared, right? So R squared is the same as Y squared. If I square my Y, this is Y, right? If I square this side and square this side, it's going to be R sine theta, then squared. Then my X as well, if I square the X component, this is now going to be the same as R squared is equal to, this will be R squared sine squared theta, then plus R squared and cos squared theta. You notice something common here, R squared throughout, right? So you can divide it throughout by R squared. What remains is just this. Because R squared is common, right? We can just cancel it. Divide by R squared throughout. Divide by R squared, divide by R squared. So this is what we are going to create. This here is the second identity, which just says sine squared of theta plus cos squared of theta. That's how we read it, is equal to 1. But in the actual sense, if you are punching, for example, what this means is that for any theta, when you punch this, you always get what? 1. For example, if I use theta to be 30, I'm just saying, if you punch sine of 30, then the answer square it, plus when you punch cos of 30, then square the answer, you always get a what? You guys get a 1. That's what we're basically saying. Yeah, so we write it like this, putting the 2 between the sine and the theta. But if it comes to replacement and punching or computing the actual value, this is how we punch it. We say sine of theta, get the answer first, then square it. That's what it means. Yeah, so this right here is our second identity. This guy right here. Yeah, or rather second rule, if I may say. So hope this is okay. The next rule that I'm going to apply is a rule that will help us to solve. So I'm going to give you these rules. There are about 32 of them. I'm going to give them to you in a way that you'll be able to follow the tutorial sheet step by step to solve whatsoever they're asking. So the next rules that I'm going to give you are rules that are going to help us to evaluate question 3, 4, and 5. Yeah, and also 6, because 6 is also these are double angle. This guy is here. So I'm going to start with something that gives us solutions on number 3. So the other rules that we're going to talk about is what we call their complementary rules. So by complementary, I just mean you already know how the ratios look like, right? We already said as long as it's theta here, all the trig ratios are all positive. I'll emphasize this again. This is what we have. So anything you punch here, for example, if theta is from the first quadrant, if it's from the first quadrant from, let me say 0 to pi over 2, that's the first quadrant, right? You know to say when you punch it, when you punch sine of that theta, it's going to be positive. It's the same as you punching, if you want the complementary angle of something, you want to complement it to the second quadrant. The biggest angle in the second quadrant is what? 180, right? 180 minus that same angle. The answers are supposed to be the same, because sine is positive both in the first and in the second quadrant. Okay, I'm just saying, if I give you to say sine theta, find the sine theta, right? Sine theta is the same as sine. Where else is sine positive? Sine is positive in the second quadrant. What's the biggest angle in the second quadrant? The biggest angle is what? Is 180. So we're going to say it's the same as 180 minus 30. So someone who punches sine 30 and someone who punches sine 150, they get the same answer. Why? Because sine is complementary to itself in the second and first quadrant. It has like a mirror image or something, because it's positive in both quadrants. The same applies to cos in the first and in the fourth quadrant. The same applies to tan in the first and in the third quadrant. So the following rules that I'm going to give you depend on the quadrant. So rule number 3, I'm just going to say sine of theta is the same as sine, we'll say 180 minus that theta. The answer is going to be the same. Then I'm also going to say cos of theta. This is when theta is from the positive quadrant, right? From the first quadrant, I mean, from 0 to 90. This is going to be the same as negative sine of 180 minus this. Why? Because this has to be cos. Why? Because cos is negative in the second quadrant. Someone who gets cos 30 is the same as someone saying negative cos of 150. Because cos 150 is supposed to be negative, right? How do we make it to be the same as cos 30? Cos 30 is going to come out positive, but this guy here is negative because cos is negative in the second quadrant. How do we make it positive? We negate it. That's the negative that you are seeing in front. Yeah, so these are just the rules that you're going to get. Now, there are supposed to be 4 sets, right? There's also tan here. Tan theta is going to be the same as negative tan. Someone who punches something from the second quadrant. So I've just given you a set for the first quadrant. We can repeat this set for all the quadrants. So they're supposed to be like 4 sets. Hope this is okay. Or maybe let me just give an illustration here. So how do you know? Like here, look at this. They're telling us to say, find the exact value of what? Of 240, right? Look at this. This is 240, right? This is 240. So you ask yourself, this is cos 240. You ask yourself, where is 240 found? Which quadrant can I find 240? Where can we find 240, guys? If you're paying attention, which quadrant can we find 240?
In the third quadrant.
In the what? In the third quadrant, right? In the third quadrant, cos is negative. So we'll put negative cos. And what's the biggest angle in the third quadrant? Guys, what's the biggest angle in the third quadrant? 270, exactly. So 270 minus 240, that's going to give us what? 30. Then you already know what cos 30 is. What's cos 30? We did this, guys. What's cos 30? Root of 3 over 2, right? So this is the exact answer as someone who punches cos 240. The person who even punches with a calculator will get something that they'll have to round off. But you are giving us the exact value in its fraction form. So cos 240 is the same as negative root of 3 over what? Over 2. You see why you won't be needing the calculator, right? Because of these simple identities that you have to be using. So this is the exact value of what? Of cos 240. So we first of all change the 240 into a special angle that we are comfortable with, using the fact that cos is negative in the third quadrant. That's what we are having. So if you punch your cos 240, you can do this at your convenient time, you'll get this exact value. So it's the same thing. This is what you've done for A is what you do for everything here, except you just have to manipulate it. If it's in radians, change it first. So which other one should we do here, guys, before our time is up? Which other one should we do here on number 3?
Before we go to number 3, for the same one which you said was cos 240 is giving me negative 0.5.
So if you punch,
if I punch the other one, it's not giving me negative 0.5.
No, it's supposed to give us what? What was this? Let's go back to this. What's cos this? Let's go to a special angle. We said cos what? Cos 30, right? It's supposed to give us, they're supposed to be the same. So let's check this. Okay, cos 30 is here. So cos 30, we're getting what? We're getting this. That was cos 30. That's what we said, right? Cos is adjacent hypotenuse. So you're saying 270. We said 270 minus 240. We're getting a 30. Then we're saying cos of 30. Oh no, cos of 30. If you punch this, they're the same, Joseph. Punch cos 30 on your calculator and also punch root of 3 over 2.
You mean I should punch root of 3 over 2, putting the cos on?
Yes, so you punch this, Joseph. Punch, let's say, cos what? This is saying what? This is saying 240, right? If we punch 240, so if we say we're subtracting 270 minus 240, this is giving us a 30. So this is supposed to be where? This is 240, which is right here, somewhere here, right? This is where 240 is. This is just before the 270 mark. So 270 is somewhere here, right? So now you want to say how do we do this? We say the biggest angle here. So let's say cos 240 is supposed to give us the same. So if we reduce this in terms of, let's say 240 minus what? Minus, okay, so 240 minus, this is supposed to give us negative, this is cos, we'll say 240, the angle that we are given here. So I'll explain this. Let me just put the answer, right?
Yes.
Yeah, this now gives you the correct answer. Yeah, so drawing the triangle is prerequisite. So if I may give you all the sets rather, because this one I know it's going to confuse a lot of people. So we're just saying, how can I say this? We're just saying in the first quadrant everything is perfect. You can just be punching, provided your angle is less than 30. So let me just write them here. Then in the second quadrant, it's also perfect because we can just say this is going to be, because the angle is supposed to be here, right? So the angle that we get here is supposed to be 180 minus whatever you had this side. So no wonder I'm just supposed to just say this is going to be positive, sine 180 minus that angle. Then for cos as well, it's simply going to be negative cos, then 180 minus the theta. Then for tan as well, it works perfect. This is going to be negative tan. Then this is 180 minus theta. Then for in this guy here in the third quadrant, if I may just give it to you, for sine theta, that's going to be negative. You say sine, because the theta is coming from this same quadrant, right? Here the theta is coming from this quadrant, which is the theta is coming from where? Let's take it from. The theta is coming from the second quadrant, right? Between 90, let me use 90 to 180, right? Yeah, so is it? Yes, the theta is here, like sine 120, for instance, it will be sine 180 minus 120. So yeah, so from here, let's say the theta is coming from this, like the 240 that we had. So the theta has to come from, not from the original guy. So to differentiate this, I'll just say, I'll call this sine alpha, because someone will think we're using the thetas from there. This will be 180 to 270. Yeah, so this is going to be the theta that you are having minus 180. Yeah, this is what you're supposed to do. We said only this will be the theta you have minus 180. Then for tan, it's still perfect. It's going to be positive still. This is tan theta minus 180. For this guy here, we're supposed to draw it like this, right? We're supposed to draw it like this. So it's supposed to be 360 minus that guy, right? So that's going to be, this is going to be cos theta, is the same as, the theta is from this quadrant. So now this is going to be cos, you say 360 minus that theta. Yeah, because we're looking for this guy, right? Which is just like 360 away from the original angle you're given. So if anything, please just write these rules because you need them to answer anything on question 2. This will be sine. This will be 360 minus the theta. I'm saying the theta in the fourth quadrant is coming from 270 to 360. It's supposed to come from here. Like if I give you 330, for instance, I ask you to say find sine 330. Sine 330 is the same as sine 360 minus this, which is just 30, right? Get this, but put a negative in front. Yeah, so that's what I mean by this. Then tan theta is equal to negative tan. Then you put your 360 minus the theta you are given. Yeah, so these are literally the rules that you need to solve these questions here on number 3. So anyone, I was saying anyone before Joseph had asked the question, I wanted you to pick any question that you feel we should do just to cement the understanding here. Which question can I try out on number 3 that you want to see?
I.
Question I, okay, question I is 5 pi over 12. So 5 pi over 12, the key first here is knowing what 5 pi over 12 is by converting it to what? By converting it to degrees, because we should be comfortable to work in degrees. So I'll convert this by multiplying this by 180 over pi. This is going to be sine. The pi goes away. 6 there is simply 2. 6 in 18, that's going to give us that. Then we're simply saying this is going to be what? This is going to be 5 by 30. That's 150 divided by 2, right? That gives us a 75. So 75 75 is already in the what? Is already in the first quadrant. So there's nothing that we can really do to simplify. The only thing that you do, though you need another rule for this, 75 is simply a combination of two special angles, which is 30 and what? And 45. So this here can be written as sine 30, the smaller one first, then plus what? Plus 45. So if you wanted, in case you're wondering why I did this, I just did the same thing that you would have done, just in a different way. I just did 1 pi is equal to what? 180. Then what will be 5 pi over 12b in degrees. So when you cross multiply, you should get the same 75. Then looking at all the special angles, we didn't learn any special angle for 75, and we cannot reduce it to anything because this is already it's already perfect, it's already acute. We do these things if your angle is not acute, right? We take it to be, we want to reduce it, that's why we do the subtractions. But this guy is already here, it's already in the first quadrant. We know it's supposed to come out as positive, but we don't know how to evaluate it because we didn't have a special angle for 75. So we look at the special angles that we learned, 30, 45, and 60. You ask yourself, what can I do with these guys to get a 75? You can simply add a 30 and a what? And a 45. Now there's a rule, though we have not talked about this. I thought there is no question that will require it on number 3. So there's a rule that says if you're looking for sine of a plus b, this is just the same as sine of a cos of b, then plus you're going to have sine of b, then you're going to have cos of what? Cos of a. So our a is 30, our b is simply 45. So now I'll just use the same formula here and do the replacements. This is basically going to be a sine 30, then you have what? Cos 45, then you have plus sine 45, then you have cos what? Cos 30. Now you know these guys, we've learned this. Sine 30 should be like what? Should be like half or something. Sine 30 should be like 1 over 2. If I'm not mistaken. Yes, that's 1 over 2. Then cos 45 is 1 over root 2 according to the special angles. Sine 45 is 1 over root 2. Then cos 30 is just root 3 over 2. That's what you have. So now the first part will give you 1 over 2 root 2 plus. The second part will give you 2 root 2. So when you add this, you just get 1 plus root 3 over 2 root 2. They want the exact answer. So this is the exact answer, but you can rationalize this by multiplying with root 2 to get rid of the root 2 at the bottom. This is going to be root 2 plus root 6. Down just gives you a 4. So this is the exact answer of sine 75. So if you punch this on the calculator and also just punch sine 35, the number has to be the same. Yeah, so now because we haven't not yet done, this is called a double angle when you have two angles. So we have not yet done these double angles. They are part of the identities. Yeah, so for now, the only questions I think that you can focus on, this is going to give you what? This is, I think you can do this, you can do that, and you can do that. You can also do that. The rest will require us to do double angles first. Yeah, so this is basically the introduction to trigonometry. Hope this is helpful. Next time when we have math, we're just going to continue from here. Then I think we just need 2 more sessions, then we'll be done with the topic. Is this okay, guys?